Welcome back. Welcome to lecture 4 of week 12 on probability theory with actuarial applications. In today's lecture, we are going to go further in questions from questions 11 to 20, where you have to always remember the 3-minute mindset. First, ponder on what is a topic. Second, what is a tool that you are going to use, and third, where is the trap. Okay, what trap you will fall prey to. Okay, so if you have this mindset, let us again deal with next 10 questions, which are question 11 to 20. Question 11, which is basically, by looking at the question you can see it is a combinatorics question. So the topic is combinatorics. What are the tools that are available? Permutations and combinations, these are the tools that are available. So let us read the question. A company had 6 male, 4 female employees. A team of 5 people is to be formed at random. What is the probability that the team has exactly 3 men and 2 women? Essentially, whether the order will matter for choosing the team or not is the key question. The answer is order is immaterial, order does not matter. So the solution will come from combinations. Perfect. Because we are dealing with this case, it is a classical probability. So the if I want to compute probability of E, it will be number of elements in E upon number of elements in S. Okay. That means I need to just find what is cardinality of E, set E, which is essentially the set which is given here, and the what will be the sample space. So the sample space essentially comes from a team of 5 people is to be formed from 10 people. So I know the sample space will have form 10 choose 5. Okay. So this is very clear. Now in how many ways you can have a team with exactly 3 men and 2 women? How many men are there? 6, right? So from 6 men you have to choose 3. So it will become 6 choose 3, and remaining 2 people are coming from the female category. So how many females are there? 4. So it will be multiplied with 4 choose 2. Okay. So this will be the cardinality of set E, the event that we are interested in, and therefore is we have actually solved the problem. The probability of E is straight away 6 choose 3 into 4 choose 2 upon 10 choose 5. Okay. Is there any answer related to this? 10 choose 5, this is obviously ruled out because it has 10 choose 3, 10 choose 5 is there everywhere. Now 6 choose 3 and 4 choose 2 is here. Okay. So this is the correct answer. Answer B is the correct answer. Okay. So that gives the solution to this problem. Theory or the way we approach this solution is given in a printed format in this way, and this is our correct answer. So we got this answer, fine. So let us move on to the next question, which is essentially a continuous random variable having a PDF 3x square between 0 to 1, and you need to compute 1 by x. So which tool to use? Lotus, law of unconscious statistician. What is there any trap? There is no trap. You just need to compute expected value of 1 by x. Do not worry about what happens at 0, because 0 is outside the interval. So that trap is, so expected value of 1 by x, it is a mere computational problem which is going to be integral from 0 to 1, okay, and then this 1 by x will be there, 1 by x 3x square dx, right, and what will this give me? It will, this x will elope here, and therefore I have simply 3x. So 3 into integral 0 to 1 x dx, and therefore it will be x square by 2. So the answer will be 3 by 2. 3 by 2 is going to be 1.5. So, this is going to be my answer. Okay. So, we have solved this problem also, very quick, very easy. We have to use lotus and get the answer. Answer is B. Okay. Let us move on to the next question, which is related to normal distribution. So, the key here is normal distribution. The topic, it comes from the topic. Then with normal distribution, the associated problem is continuity correction. So, here we are dealing with daily rainfall. So, this can be a continuous random variable. So, no continuity correction needed here. Okay. And then what is mean and variance given? Yes, both are given. What do I need to compute? X less than 48. Okay. What is remaining is standardization. So, you can write here mu is equal to 40, sigma square is equal to 16, which implies sigma is equal to 4. And then you ask this question, which is probability of x less than 48 is essentially equal to probability of x minus mu, which is x minus 40 upon 4 less than 48 minus 40 upon 4, which essentially means probability of z less than 8 by 4, which is 2. So, this is effectively capital 5 of 2. Okay. Do I know the answer? I can easily look at the normal table and get this answer, which is straightforward 0.9772. Okay. So, is there any answer related to this? Yes, answer D. So, we have actually solved this problem as well. Okay. Nothing great. So, this you can consider this as a trap, sigma square versus sigma. If you forget to do that, then you may land up in trouble, right. So, that you have to check all the time. Okay. So, let us move on to the next question, which is question 14, and here you are given two variances, one correlation, and you are asked to compute variance of x plus y. So, here the very simple thing is, first write down the formula for variance of x plus y. So, that is essentially variance of x plus variance of y plus 2 times covariance of x comma y. But this covariance of x comma y is actually rho, which is the correlation coefficient, into sigma x and sigma y. Okay. This is what you need to remember. If you remember this, then the calculation is just a simple algebra. So, let us put all these things in place. Variance of x is 25, so sigma x is actually 5. Variance of y is 16, so sigma y is actually 4. So, I have all the things here. Correlation is rho, which is 0.5. So, 0.5 into 5 sigma x into 4, which will give me 20 divided by 2, which is 10. Okay. And then I need to substitute everything here. What is variance of x? 25 plus variance of y 16 plus 2 into 10. Okay. So, that will simply give me this thing will give me 41, this thing will give me 20. So, together this will be 61. So, the answer to this question is 61. Great. So, we have done this. So, we have used random variables are dependent, rho is not equal to 0, and we have full variance formula. We have evaluated everything. Let us move on to the next question, which is related to what we considered in week 5, transformation. X is a uniform random variable, and now let me list here. X is uniform on 0 to 1, okay, and then you have y which is equal to minus ln of x. Here you have to look at this transformation, whether log, which is natural log, is it a monotonic transformation? Yes, it is monotone. So, ln is monotone. Minus ln is also monotone. One is monotonically increasing, another one is monotonically decreasing. Fine. So, I have monotone transformation. So, my both methods, Jacobian method and CDF method, both will work. However, we will choose to use the CDF method and solve the problem. Okay. So, what is a CDF method? If I want to compute Fy of y, I will write it as probability of y less than or equal to y, which is essentially probability of y is g of x. So, minus ln of x less than or equal to y, and then I will take this minus sign on the other side, which gives me probability of ln of x greater than or equal to minus y. After that, I will take this ln, because ln is a monotone function, I will take the inverse transform of it, and that will give me probability of x greater than or equal to e raised to minus y. Okay. Then what is probability of x greater than or equal to e raised to minus y? Because x is a uniform random variable, probability of capital X less than or equal to x is equal to x. Okay. So, essentially probability of x greater than or equal to x will be 1 minus x. Okay. So, that will give me this probability to be equal to 1 minus e raised to minus y, and this is my CDF. Okay. What is the support of y? X is varying from 0 to 1, but minus ln of y will vary from 0 to infinity. Okay. So, this is what is the support of y. And now what am I asked? Am I asked cumulative distribution function? No, I am asked density function. So, I will take the derivative of this d dy of 1 minus e raised to minus y. So, this is derivative of e raised to minus y is e raised to minus y. Okay. So, one minus sign will cancel with another minus sign. So, it becomes e raised to minus y, and that is for y greater than 0 and 0 otherwise. So, here in this case e raised to minus y is option A, that is the correct answer. Okay. You can also use the Jacobian method and you can simply solve it. However, you can try it on your own. This is slightly longer method, so I chose this method, but it is a safe method. Okay. So, this is the theory behind or the procedure behind what we have done. Okay. Let us move on to the next question, which is question 16. This comes from week 6 and 11 and it is related to compound model. So, in the portfolio, n is the number of claims with expected value of n equal to 10. Each claim has a payout y, which is expected value of y equal to 500, and s is the total payout of the portfolio. So, I want to find expected value of s. Very straightforward, nothing is crucial. Do I know what is expected value of n? Yes, I do know, it is 10. I know expected value of y, which is 500. Now, I want to compute expected value of s, but law of total expectation tells me that this is going to be expected value of n into expected value of y. Okay. So, this is actually going to be equal to 10 into 500, which essentially means this is going to be 5000. Very simple, that is the answer. There is no difficult thing apart from knowing this relation. So, this is the key thing. Okay. So, these are the procedural steps which you can go through at leisure time. Now, let us move on to the next question, which is question 17, and this is related to MGF of sums. Now, you have been told that this particular thing is a gamma random variable, this particular thing is another gamma random variable. The crucial fact is lambda is equal to 1 in both cases. So, the resultant we already know, whether you know MGF or not, x plus y will follow gamma with, since lambda is equal to 1 is same, I will simply use this alpha 1 alpha 2 and this will be alpha equal to 5. I know this. Okay. Therefore, my expected value of x plus y will be nothing but alpha by lambda, which is 5 by 1, which is equal to 5. So, my answer should be D. Correct? Straightforward. You do not really need MGFs here. However, to guess this particular thing, which is x plus y follows gamma, you may use MGFs. That is, you will say m x plus y of t is actually equal to mx of t into my of t, and now because it is lambda, so you can easily say lambda is equal to 1 lambda upon lambda minus t raised to, what is alpha here, 2 square, 1 upon 1 minus t raised to alpha here is 3, and then you will essentially do 1 upon 1 minus t raised to 5, and therefore, you can conclude because of this MGF x plus y is gamma alpha equal to 5 and lambda equal to 1. This is very easy and you can easily solve this in 2 minutes. Okay. So, these are the expectation steps. What I have used here is this particular thing also can be used and this also can be used. So, both ways it is very easy problem. Okay. Let us move on to the next problem. So, here you are essentially asked to find a probability of x greater than or equal to something, a tail probability where the only mean is given. So, definitely this is going to be a Markov inequality problem, and for Markov inequality we need a non-negative random variable. So, x greater than or equal to a is going to be less than or equal to expected value of x upon a. So, I will simply use that and get this answer. So, which is effectively 100 upon 400, these two zeros go away, this number is 0.25, answer is C. Very easy, very simple, straightforward. What we have done? We have actually given bound which we have studied in week 8, we have used Markov inequality and the answer was straightforward. Let us now move to question 19. So, question 19 says a fair coin is tossed 400 times, H is the number of tosses in these 400 trials. What we need to compute is probability of H greater than or equal to 215. It is straight away mentioned that you have to use normal approximation with continuity correction to estimate this probability, correct. So, let us first apply that continuity correction, which is probability of H greater than or equal to 215. Okay. So, as you are already familiar, this is equivalent to probability of Y normal greater than 214.5, because I have to distribute the mass associated with this 215 to a 0.5 variation later, right. So, this is what is important. So, this is the first step. So, I have to approximate normal. So, I have to identify the corresponding set. So, this is Y normal greater than 214.5, perfect. Now, let us move on to normal distribution, corresponding normal distribution, what are the parameters? So, this distribution which is say H is actually a binomial distribution with number of trials equal to 400 and probability of success, because it is a fair coin, is 0.5. Therefore, I know that this mu H will be equal to NP, which is 400 into 1 by 2, which will give me 200, and sigma square H, which will be equal to 400 into 1 by 2 into 1 by 2, which is 1 by 4. So, 400 divided by 4, that gives me 100. Therefore, the sigma H associated with this will be 10. Okay. So, this is the entire cookbook or the recipe, the raw material that I need. Now, I need to understand how this H is working with normal. Therefore, we have already applied the continuity correction. Okay. So, essentially now the problem reduces to probability of y normal greater than 214.5. And now you already know we will apply the standardized step. How will I standardize this? Basically, I will subtract the mean from this y normal. So, y normal minus what is the mean? Mu h, which is 200, upon sigma is 10. So, upon 10 greater than 214.5 minus 200 upon sigma is 10. So, 10. Okay. So, this effectively means this is equal to probability of random variable z, which follows a standard normal distribution, greater than 14.5 divided by 10, which is 1.45. Okay. This effectively means this is a probability of 1 minus standard CDF of 1.45. Now, notice the point. Here I have been given 1.4 and 1.5, not 1.45. How will I use this information? Essentially, this function is increasing, right, that we already know. So, 9132 and 9323. So, we will approximate phi of 1.45 by basically considering phi of 1.4 and plus phi of 1.5 divided by 2. Okay. Had I not applied that continuity correction, then this would have been phi of 1.5, and you will easily get phi of 1.5, and one of the answers may match this answer, but that is not correct. So, now what I got, it is the approximation, and therefore, phi of 1.4 is 0.9192 plus 0.9332 upon 2. So, what will be the answer for this? You just calculate all this and you will get the answer to be equal to 0.9262. Okay. So, now I will simply approximate that. I will simply use this value and get the approximate answer 9262, which will give me something like 0.0738. Okay. So, if I round this off to nearest 2 decimals, 3 decimals, this gives me the answer to be equal to 7.4%. So, this is the correct answer. Okay. Let us view the final solution to that, which is given here. Okay. This completes 19. We will move to question 20. Let us solve the next problem, which is related to policy limits. X has uniform distribution for ground up loss, which is in the interval 0 to 100. The policy has limit u equal to 40. So, this is kind of upper bound on the policy, and the payout therefore is minimum of x and 20, and you are asked to compute expected value of y. Straightforward question. Essentially, you are asked to compute expected value of minimum of x and 40. That's the idea. Okay. So, which tool will you use? Here uniform distribution is given, not exponential. So, I need to use the survivor shortcut, where I have a policy with limit expected value of x L, where L is the limit of the policy. Then I will write this as integral from 0 to L s x x dx, right. So, this is the formula that I need to use straight away. But what is Sxx? Sxx is essentially probability of capital X greater than small x. So, do I know anything about this uniform random variable? The answer is very simple. I know the CDF Fxx of this uniform, which will be x upon 100 for 0 less than x less than 100, right. So, 1 minus of this will be the survivor function, and therefore, I know Sxx of this to be equal to 1 minus x by 100, 1 minus x by 100. Okay. So, this is the survival function. So, I know this is going to be 1 minus x by 100, and then what is remaining? Then it is just integrating this out. So, let us integrate this out, which is integral from 0 to L, L is 40 here, 1 minus x by 100 dx. You can easily see this to be equal to x minus x square by 200 from 0 to 40. Then it is a matter of doing algebra, and then you will get this expected value of y to be equal to 40 minus x square, which is going to be 1600 by 200 minus 0, everything is 0. So, there is nothing. So, what I got is this is going to be 40 minus 8, which is equal to 32. So, is there any answer corresponding to 32? Yes. So, I got my final answer to be equal to 32. Okay. So, here is the details of the calculation or the procedure. Okay. Then we have completed up to question 20 all problems, and we have come to the end of second particular lecture for problem solving. So, here is the summary. We have 2/3 of the way done. We have seen huge mix of topics from week 1 to the week 10, and the key idea here, by the time you must have realized, is you read the question, identify the topic, and then apply the specific tool or shortcut for that topic. In the next lecture, we will cover remaining 10 questions and we will conclude the course. Thank you for listening to this lecture.